All right, everybody. Time for another video here. Let me just adjust the camera so you can see me. All right. So in this video, we're going to start looking at our first two types of chemical reactions. We're looking at the two most basic types of chemical reactions they are, and that's synthesis and decomposition. Synthesis and decomposition, as you might suspect, are opposites of each other. When you have a synthesis reaction, synthesis reaction is simply using building blocks So in a synthesis reaction, you use two or more building blocks. They can be elements, they could be very small compounds, it doesn't matter. But you use both of these, or all three or all four, how many of you are, to build one and only one more bigger complex molecule. In a synthesis reaction, you're only ever going to have one product. You're not going to see more than that. The opposite of a synthesis reaction is a decomposition reaction. By the way, RXN is an abbreviation for reaction. I'm going to use that a lot in here. So in a decomposition reaction, they're opposites. If a synthesis uses two or more building blocks to build one complex molecule, a decomposition reaction, one molecule is going to break down into two or more simple molecules or elements. In a synthesis reaction, we take our building blocks, A and B, and they build a more complex molecule that's made out of both A and B. Notice there's only one product. For a decomposition reaction, we have the exact opposite. We take our complex molecule and it breaks down into its building blocks. Notice, instead of one product, we now only have one reactant. And that's really all there is to synthesis and decomposition reactions. They're the easiest ones to identify because you're only ever looking for one single thing. Now, we do have some special cases. The most basic case, you take two elements to make a compound, or you break a compound down into its two elements. And those are reactions of binary compounds. So we're going to go through some examples here to show you how to predict something. So, example type number 1. Binary compounds. So let's start with the positive. Let's build synthesis reaction. So with this synthesis reaction, the way we're going to identify it as a synthesis reaction is we're going to see that we have two reactants and it's going to form one product. So in this case, we're going to start off with two elements. So we have magnesium plus oxygen. In a synthesis reaction, it's easy to see right away because it's two elements. Two elements reacting is always going to be a synthesis reaction. So to make this compound, we just combine the two elements together. Magnesium and oxygen. If we look at our periodic table, we see the charge on oxygen is -2, and the charge on magnesium is a +2. So we just need one of each. They form MgO, magnesium oxide. We're not done, though. We have to balance this equation. Two oxygens there, only one oxygen here. So we need to make sure we have a 2 in front of that and a 2 in front of that to balance that. So that's the synthesis reaction for magnesium oxide. The opposite of that is the decomposition reaction. In this case, you're just going to see this. This is a dead giveaway that we have a decomposition reaction because there's only one compound. And it's going to break down into its elements because there's only two elements in there. It's a binary compound. That's what the term binary means. So we break this down into its elements, magnesium and oxygen. Notice for oxygen, I always put O2. Oxygen is one of those elements that's a diatomic element when it's by itself. Those diatomic elements are circled on your periodic table. And since they're complete opposites of each other, we just put a 2 there and a 2 there, and we're balanced. So this is a synthesis and decomposition reaction for a binary compound. But we also have different types of reactions. Some special cases that signal synthesis or decomposition. So the first special case we want to talk about is when you have metallic oxides. That's a D. So metallic oxides or hydroxides. You see why I put oxides and hydroxides. They're going to be opposites of each other. So a metallic oxide or hydroxide is any metal plus oxygen or hydroxide. A metal plus oxygen gives you the metal oxide. A metal plus hydroxide gives you the metal hydroxide. So let's look at our synthesis reaction. So the synthesis reaction for our metal oxide. You're going to see our metal oxide. So in this case, I'm going to use calcium oxide. And it's going to react with water. So this is special case number 1, metal oxide with water. A metal oxide plus water gives you the metal hydroxide. And this equation happens to be balanced already. We have enough on both sides. So metal oxide plus water, metal hydroxide. The opposite of that, the decomposition reaction, instead of starting with a metal oxide, we're going to start with a metal hydroxide. So the metal hydroxide in this case is calcium hydroxide. And it's going to decompose into the metal oxide and water. Like I said, these are all opposites of each other. Synthesis and decomposition are the exact same reactions, just flipped around. So that's special case number 1. Special case number 2 is going to be a metal carbonate, or a metal oxide and carbon dioxide. So, if you have a metal oxide again, and instead of adding water to it, you add carbon dioxide. This is the synthesis reaction. You're not going to form a metal hydroxide, you're going to form what's called a metal carbonate. Calcium carbonate in this case. The opposite of that, the decomposition reaction, we're going to take the metal carbonate and it's going to break down into the metal oxide and carbon dioxide. All right, another special example or another special case of a synthesis reaction. This is the metal chloride and chlorate. And oxygen. So, a metal chloride is any metal bonded to chlorine. So here's the synthesis reaction. We have our metal chloride. We'll use the basic sodium chloride and react it with oxygen. We're going to get a metal chlorate. And now we got to balance this equation. So the synthesis reaction, we have our metal chloride, sodium chloride. we're reacting it with oxygen and we get a metal chlorate, sodium chlorate. The opposite of that is the decomposition reaction. The decomposition reaction, in this case, we start with our metal chlorate. And we decompose it down into the metal chloride and oxygen. All right, the last special case we have is what we call a reaction with a metallic oxide and a water. No, not water. Sorry. Check that. A non-metallic oxide in water. So our last special case is the non-metallic oxide. And water. With the non-metallic oxide and water, we see different things. Your non-metallic oxide is any oxygen-containing compound that doesn't have water in it. So if we look at the synthesis reaction, let's use good old carbon dioxide. We'll take CO2 and we'll react it with water. When we react CO2 with water, we form what's called an oxyacid. So if you remember, back when we were naming acids, we said an acid is anything that contains hydrogen as the cation. And then what we're left over with is an oxygen, a carbon, and two more oxygens, which forms the carbonate ion. And that is carbonic acid. So for the synthesis reaction, you take your non-metal oxide, you react it with water, and you make an oxyacid. It's called an oxyacid because it's got oxygen in it. The decomposition of an oxyacid is going to be the opposite. So the decomp reaction you're going to start with your oxyacid, and it's going to decompose into the non-metallic oxide and water. And that's synthesis and decomposition reactions in a nutshell. As always, if you have any questions, make sure you send them my way. Review all of your resources in the Astro Bulletin, and do those practice worksheets. Even though I don't collect practice, it is very beneficial for you. The answer keys will be posted so you can compare your answers as well. Good luck, and we'll see you in class.